Welcome to Fun Facts Daily, your source for just the good stuff. Monday through Friday, we're bringing fun facts and news you can use, all carefully curated to uplift and inform. So give yourself a break, relax, and learn something awesome in just a few minutes every day. Hi everyone, I'm Kyle Wood, and today we're going to be learning about STEAM. That's science, technology, engineering, art, and math. With school starting up for many of our listeners, it's the perfect time to celebrate the amazing ways these subjects work together. But before we get into the facts, let's warm up our brains with a little challenge to see if you can tell fact from fiction. Consider this. Astronauts in orbit on the International Space Station experience a sensation of weightlessness, but it isn't because of a lack of gravity. They're actually in free fall around the Earth. What do you think? Could that be true? We'll find out at the end of the episode. Now for your word of the day. Our word for today is interdisciplinary. Interdisciplinary is an adjective that describes something involving two or more different academic subjects or areas of knowledge. If you're taking an interdisciplinary approach to a project, it means you're not just looking at it from one angle like a scientist, but also thinking like an artist, an engineer, and a mathematician all at once. It's about combining knowledge and methods from different fields to solve a problem or create something new. Studying the word itself can actually give you a great clue to its meaning. It comes with the Latin prefix inter, which means between, and the Latin word disciplinia, which means teaching, learning, or a branch of knowledge. So interdisciplinary literally means between branches of knowledge. STEAM is the ultimate interdisciplinary concept because it's founded on the idea that innovation happens when these subjects are not kept separate, but are woven together. A beautifully designed smartphone, for example, requires brilliant engineering, cutting-edge science, intuitive technology, creative art and design, and the precise logic of mathematics. Time for your daily high five, our top 5 fun facts about STEAM. Number 1, we've got a science fact. You are literally made of stardust. That's right, the building blocks of your body were forged in the heart of a star billions of years ago. Except for the simplest elements like hydrogen and helium, which were created during the Big Bang, almost every other element was created through nuclear fusion inside stars. Elements like the carbon in your cells, the oxygen you breathe, and the iron in your blood were all manufactured in these incredible cosmic furnaces. When massive stars reach the end of their lives, they often explode in a spectacular event called a supernova. This explosion is so powerful that it scatters all these newly created heavy elements across the galaxy. Over billions of years, clouds of this cosmic dust and gas came together to form new stars, new planets, and eventually everything on Earth, including you and me. And number 2, we've got a technology fact. The world's first computer programmer was a woman who lived over 100 years before the first modern computer was built. Ada Lovelace was an English mathematician and writer born in 1815. She was the daughter of the famous poet Lord Byron, and she was encouraged to study math and logic from a young age. She worked closely with Charles Babbage, the inventor of a theoretical calculating machine called the analytical engine. While Babbage saw his invention as a powerful number cruncher, Ada saw its potential for so much more. In 1843, while translating an article about the analytical engine, Ada added her own extensive notes. Within these notes, she included what is now recognized as the very first algorithm designed to be carried out by a machine. She imagined a machine that could go beyond mere calculation and could one day create music or art. Her visionary work laid the conceptual foundation for modern computing, earning her the title of the world's first computer programmer. Number 3, An engineering fact. Ancient Romans engineered a type of concrete that could heal its own cracks. Many ancient Roman structures, like the famous Pantheon and the Colosseum in Rome, are still standing in remarkable condition after 2,000 years, outlasting many modern buildings. For decades, historians and scientists were puzzled by the incredible durability of Roman concrete. The secret, it turns out, lies in a special recipe that included volcanic ash, lime, and seawater, creating a material that is far superior to our own modern concrete in certain ways. The Romans' mixing process left behind small white chunks of lime known as limeclasts. Scientists used to think these were a sign of sloppy mixing, but they're actually the key to the concrete's longevity. When tiny cracks form and rainwater seeps in, the water reacts with these limeclasts. The clasts dissolve and then crystallize, filling the crack and healing the concrete, sometimes making it even stronger. Number 4, an art fact. For centuries, the most brilliant blue pigment was more rare and more expensive than gold. Today, we have every color of the rainbow at our fingertips, but this wasn't always the case. For artists in the Middle Ages and the Renaissance, a vibrant deep blue known as ultramarine was the most sought after but also most expensive pigment in the world. It was made by grinding the semi-precious gemstone lapis lazuli into a fine powder. The name lapis lazuli actually would translate to beyond the sea, but this stone was mined almost exclusively in a small area in the mountains of what is now Afghanistan. And even when they did obtain the gemstones and went to the work of grinding them into dust, only about 3% of that dust was actually usable pigment that they could then mix into their paints and create what they wanted. All of this labor involved created a tremendous cost around ultramarine, and so that pigment and that paint was used very sparingly and reserved for just the most important parts of a painting. Using ultramarine on a subject in a painting was a huge sign of respect, showing how important that figure was. And that's why in a lot of Renaissance work, depictions of the Virgin Mary will often have blue robes signifying her holiness and heavenly status. The story of this color is actually a perfect example of how art is connected with geology, chemistry, and global trade. And it's a bit of a technology story too, because in the 19th century, a couple of inventions came about that really revolutionized the use of paint. One of the best known bits of technology that shook up the art world at that time was the camera, but some lesser known would be things like the tube of paint and the development of synthetic pigments like Prussian blue. And I would argue those bits of technology, the synthetic pigments, the portable tubes of paint, and the new development of the camera led to a radical shift in our art history when we talk about people like the Impressionists who went to paint outside, drawing from direct observation of nature, and experimenting with all of these different colors, making them visible because they were the new technology of the day. And competing with the technology like the camera, which couldn't capture color back then. Our fifth and final fun fact for today, it's a math fact. A special mathematical number, approximately 1.618, appears all over the place, from pine cones to famous paintings. This magical number is known as the golden ratio, and it's often represented by the Greek letter phi. The golden ratio is found when you divide a line into two parts, so the ratio of the whole line's length to the longer part is the same as the ratio of the longer part to the shorter part. While that might sound complicated, our eyes find this proportion to be naturally balanced and aesthetically pleasing. We can see the golden ratio all over the natural world. It appears in the spiral arrangement of seeds in the flower head, the chambers of the nautilus shell, the shape of spiral galaxies, and branching of trees. Artists and architects have also used this ratio for centuries to create works of beauty. It's believed to be the basis for the proportions of the Parthenon in Greece, and even thought to be present in compositions like Leonardo da Vinci's Mona Lisa. It's a beautiful reminder that mathematics is the hidden language that describes the world around us. Now for some news you can use. Here's a tip that combines every part of STEAM in one incredibly fun activity: making your own movie special effects using your smartphone or tablet. Long before computer generated imagery, early filmmakers had to be clever inventors, and you can use their tricks today. This is a perfect way to experiment with science, how the light and cameras work, technology, your phone and editing apps, engineering, setting up your shot, art with the creativity and storytelling, and the math of timing your edits. A true pioneer of this was the French filmmaker Georges Méliès. Back in the late 1890s, he discovered his first special effect by accident. His camera jammed while he was filming a street scene. After he got the camera fixed and started recording again, the scene looked totally different. When he got the film developed, he saw that a bus going through the shot seemed to suddenly transform into a hearse. He realized he could stop the camera, change something in the scene, and then start filming again to create magical appearances, disappearances, and transformations. He also experimented with double exposure, where he would film a scene, then rewind the film and record over it again to make ghostly figures appear. You can become the next Georges Méliès with these two simple effects. First, try the stop trick, just like he did. To make an object or a person magically disappear, start by placing your phone or tablet on a stable surface where it won't move, ideally a tripod. Start recording a person sitting in a chair, then stop recording. Have the person walk out of frame, leave the chair, and make sure not to bump the camera or the chair or anything else. Press record again for a few seconds, and after you splice those two clips together, when you play it back, the person will seem to magically vanish into thin air. A second trick you might try is making a ghostly figure. There are many online video editors like Adobe Express that will allow you to layer your video clips. First, record the background scene for 10 seconds. Then record a separate video of a friend, maybe with a sheet over them, walking slowly through the same area. And again, you want to keep your camera steady on a tripod. In your editing app, place the ghost video clip on top of the background clip. Look for a setting called opacity or transparency, and lower it for the ghost clip. Suddenly, your friend will look like they are a see-through phantom haunting the room. Experimenting with these tricks is a fun, hands-on way to bring all the elements of STEAM to life. Now for the moment you've been waiting for. At the beginning of the episode, I asked about astronauts floating in space. Do you think they feel weightless because of a lack of gravity? Or are they actually in a constant state of freefall? Well, the truth is, astronauts on the International Space Station will feel weightless because they're in freefall. That's a fact. The International Space Station orbits at an altitude of about 250 miles, where Earth's gravity is still about 90% as strong as it is on the surface. So gravity is definitely still pulling on everything up there. A great way to understand this is to look at how astronauts train for weightlessness here on Earth. They use a specially designed airplane that flies in giant arcs, like a roller coaster in the sky. As the plane climbs steeply and then nosedives over the top of the arc, it begins to fall. For about 20 to 25 seconds, the plane, the passengers, and everything inside are all falling together at the same rate. They feel completely weightless and can float around the plane's cabin. That's exactly what's happening in the space station, but on a much more grand scale. It's constantly falling toward Earth, but it's also moving sideways at an incredible 17,500 miles an hour. That immense speed means that As it falls, the curve of the Earth drops away beneath it at the exact same rate, so it never gets any closer to the ground. It's in a permanent state of freefall, creating that amazing and continuous sensation of weightlessness. Now, I hope you enjoyed learning a bit about steam with me today. Be sure to tune in every weekday for even more fun facts. Fun Facts Daily is an Airwave Media podcast. It was written, recorded, mixed, and edited by me, Kyle Wood. Thanks for sharing a part of your day with me. Be sure to follow Fun Facts Daily on your favorite podcast app so you can keep the good stuff coming your way every day. And if you like the show, please do me a favor and leave a kind rating, review, or just tell your friends about it.